Okay, we're on revision 4, mostly focused on motion graphs for our transportation test coming up. So we've got a position versus time graph, and position has the unit of meters and time usually in seconds. So a positive constant velocity. So on a position graph, velocity is shown by changing position. That shows that you're traveling with some kind of speed. So a positive velocity equals a positive slope. And so that means that we have to do something like this, where it's going upwards. And I'm assuming that we're starting at position 0 unless otherwise stated. Then it says the object stops moving, and that means that the position is going to stay the same for a while. So this is the first bit, positive, and this is B, stops moving. And then it begins moving backwards at a constant velocity. So if you start moving backwards, you're moving back towards the starting point, which means you're moving with a negative velocity. So that means a negative slope. So this is negative slope. Back towards the starting point, back towards 0. It doesn't specify for how long. Begins accelerating in the positive direction. So accelerating means not only that it's going positive and the slope should be positive, but that it's because it's accelerating, that means it's getting faster and faster. It needs to be getting steeper and steeper. We need to keep increasing the slope. So that would mean like all of a sudden it starts doing this. Oop, sorry, my thing turned into a line, but it'll curve up like that. So that's what acceleration looks like on a position graph, because we have the slope of this is changing and getting steeper over time. Okay, and then it says begins slowing down until stopping. So if it stops, then the position line needs to go flat. So we're going to stop going up as quickly, and this is actually decelerating until we get to a flat line again. So this part would be E, and the point at which it changes from D to E would be somewhere around here. Notice this part is getting steeper, and this part it's getting less steep, so that shows slowing down. Okay, now velocity versus time graph. We've got velocity, which is in meters per second, then here's time in seconds. So in this graph, our acceleration can be shown with slope of the velocity time graph. Okay, starts with a positive constant velocity for 5 seconds. So a positive velocity here that's constant. I need to show that the velocity is staying the same, and so this is for 5 seconds. Then it stops moving in 1 second. So that, I think what that indicated is that it comes to a stop in 1 second. So that would mean that it goes from having a constant positive velocity to having 0 velocity, right? So being stopped is equivalent to having 0. Okay, stopped equals velocity is 0. Whereas on this one, when you're stopped, it just means that your position stops changing. So you might still be up here, you could be down below. It's just that it's not changing anymore. Whereas when you're stopped on a velocity graph, you have to be down here at 0. You have to have 0 velocity. Then it speeds up to a constant negative velocity in 1 second, and then keeps that velocity for 5 seconds. This is kind of tricky. This is probably way trickier than a test question would be, but it's worth trying. Let's see. So we're going to speed up to a constant negative velocity in 1 second, and then we're going to hold it for 5 more seconds, so that'll go to time 12. So I'm going to speed up. That means my velocity is changing. So I did that for 1 second, and then I stay at that velocity for 5 seconds. Then I slow down for 5 seconds to a rest, which means I go back towards 0 by time 17. And after 2 seconds of rest, which is till time 19, then I accelerate for 4 seconds, and that means I'm getting faster in the positive direction for 4 seconds. So that means something like this until time 23. So more complex, I think, than what you'll actually be asked to draw, but it's still helpful to kind of think through these different types of motion and what they would look like on a position versus a velocity graph.